3.1b. So let's summarize the first derivative test for relative extrema. All right, here's the first picture. If f prime of x is greater than 0, that slope is greater than 0, and f prime of x is less than 0, and right here f prime of x equals 0, then this point is a relative max. Going the other way, if f prime of x is less than 0, it's negative, and f prime of x is greater than 0, it's positive, then f prime of x equals 0, then we have a relative min. Okay, so we have to notice that our slope of our tangent lines has to go from positive to negative, then we've got a max. Here it goes from negative to positive, then we have a min. If it doesn't do either, then we don't have a max or a min. So now let's apply this to an actual problem. We're going to look at f of x equals x cubed minus 3x plus 1. All right. Part A, find all x where f prime of x equals 0. Find all x where f prime of x equals 0. So we have to take the derivative of f of x. F prime of x equals 3x squared minus 3. Find all x where f prime of x equals 0. So we're going to set this equal to 0. 3x squared minus 3. And then we're going to go ahead and factor, pull out of 3. We get x plus 1 times x minus 1. So where does all of this equal 0? Where x equals negative 1 and x equals 1. These points right here, we call these critical values. Critical values. Okay, so we know our critical values are at negative 1 and 1. So let's draw two pictures of what this might look like. We don't know quite yet. So letter B, where is f increasing / decreasing? Okay, so let's draw two examples of what might be happening based on the information we have. So we have negative 1 and 1. We're going to do the same thing over here. Negative 1 and 1. Okay. We don't know how far up or down they are going, but we know for sure that I'm just going to go make this something like this. We know for sure at this point that f prime of 1 equals 0 because 1 is a critical value. All right. Again, we don't know how high these are going up, but we also know that f prime of negative 1 equals 0 because it's a critical value. So in this case, we could see it's either the slope, we can see that this is increasing, we could see this is decreasing, and this is increasing. We could think of the same thing as the slopes of the tangent lines at any of these points. This will be positive, these will be negative, and these will be positive. So that's one possible way that it could look like. Now, it could also look like this. It could be up here going this way. Where the relative max is above the y-axis and the relative min is below the y-axis. So here we have f prime of 1 is equal to 0. And f prime of negative 1 is equal to 0. All right, so it could be either one of these pictures right here. In this case, we could see that this would be negative. The slope would be negative for all those x's in there if we took the derivative. And here would be positive, and here would be negative. This is decreasing, increasing, decreasing. So which way is it? We don't know. So we're going to test. We're going to put -1 and 1, and I'm just going to put 0. And we're going to test the intervals to see what happens. Okay, so here we're going to test from -1 to -infinity. So I'm going to split up these intervals. In this interval from -1 to 1, and then this interval from 1 to positive infinity. So we're going to test this point, some point in this interval, some point in this interval, which I'm just going to choose 0 because it's easier to work with, and some point in this, and see what happens. So how about -2? Let's test x equals -2, because -2 is in that interval right here. F prime of -2 equals 3 times -2 squared minus 3. And that equals 3 times 4 minus 3, which equals 9. Now 9 is greater than 0. Since 9 is greater than 0, where we have x equal to -2 and we take the derivative, that means that this is going to be having a positive tangent line, I guess you could say, increasing. So we're going to put a positive there because 9 is greater than 0. Okay, now let's look in between here. Let's test x equal to 0 because that's easy. So I'm going to test x equal to 0. F prime of 0 is 3 times 0 squared minus 3, which is just -3. Now that's less than 0. So between here and here, we're going to put a negative there. Okay. Now for this one, let's just pick 2. Because 2 is in between 1 and infinity. So we're going to test x equal to 2. So f prime of 2 is 3 times 2 squared minus 3, which also equals 9, and that's greater than 0. So we're going to put a positive here. So now looking at our graphs, which graph matches this? Positive, negative, positive. This one does. So basically our picture is going to look like this, and therefore we know that we have a relative max at x equal -1 and a relative min at x equals 1. So we're going to state that now that we know what this picture is. It says, where is f increasing and decreasing? Well, we're going to state two things. We're going to say f prime of -1 is a relative max, and f prime of +1 is a relative min. And we say f is increasing on, and then we state our intervals, -1 to -infinity. We actually write them the other way, so I'm going to erase that. We put the lesser number on the left side, -infinity to -1, and it's also increasing here from 1 to positive infinity. Okay, and then we say f is decreasing from -1 to 1, -1 to 1. Okay, let's do letter C now. And then we are done with 3.1. Letter C, well, we already answered this question. I went ahead of myself. Find the relative extrema of f. Okay, I guess we could word it, f has a relative Let me write this again. F has a relative max at point. What would the point be? We know our x is -1, but we don't know what the y is. How could we find that? Well, we just plug it into our original equation. So we put that into our original equation. And our original equation was x cubed minus 3x plus 1. That's our original equation. So let's put a -1 in there. -1 cubed minus 3 times -1 plus 1, which is -1 plus 3 plus 1, which equals 3. Okay. Now sometimes they'll word it, they'll say this, and it's different from what I've been wording. They say the relative max is, because that's the y value. That's how high we would go on the graph. We'd go up to 3. Okay. So now do the same thing for the relative min. F has a relative min at, so now we have to put a 1 into our equation. Oops, what was our equation? It's -3. I thought so. Okay. That's 1 minus 3 plus 1, which equals -1. So we say F has a relative min at 0.1, -1. So this is a point. And we say relative min is -1. That's the y value. That's how low it will go.